happened. It has no knowledge that it was ever taken over and hijacked for any length of time at all. Some notes on that. Why in the heck would anybody ever do that? A little bit of a less of a memory forensic residue. There are some traces that threads might have been launched via create remote thread, and certainly APC function calls would have their residue as well. If we hijacked the main thread and launched launched a new thread from there, the thread start address would be originating from someplace that it would be originating from within that process, as opposed to being obviously a remote thread start. And my website where you can get this stuff is my rnicrosoft.net. It's not Microsoft, it's me. Let's take a quick peek at the binary. So I'm just going to run binject here with a -h. Actually, let me make this a little bit bigger. I forgot. Properties. Font. 20. Okay. Alright, so when it ran it with the -h option, you can see all the different command line parameters it takes. I didn't talk about every single one of these, but you get the idea. What I have in this directory is a little block of shellcode, which is just going to pop up a message box, and I have notepad.exe here. When I run this notepad.exe, it just runs. It does its normal notepad stuff. That's kind of cool. I can use binject. I can say -i notepad.exe -o hacked notepad.exe. I say -d and give it my message box shellcode. What I'm going to do now is give it that -t switch. This is going to force the message box shellcode to be a TLS callback. And it just runs. It doesn't spit out anything. Like I said, very simple, easy to use tool. Now when I run hacked notepad, first thing that pops up is this, lol Blackhat, I'm in your process, and then notepad runs. That's pretty cool, but you could have achieved the same functionality there with an entry point redirect. Let's actually take a look at the binary. I'm going to pull it up real quickly in PE view. You see what it did was add a section called .nic down here at the bottom, and inside of that is our TLS directory, and we have a TLS callback pointer sitting right here. So it's done all this stuff. It's made the section. It's set up the callbacks and every piece of data in here that will actually make this thing work. And inside of that callback is, of course, our malicious code. And when you pull this up in IDA, the first thing you're looking at, the entry point itself is completely unchanged. This is the normal entry point of notepad.exe. So it's a little bit stealthier than an entry point redirection right there. So another kind of advantage of binject, and I think I mentioned something about it earlier, about being, it has a pretty good algorithm for actually adding sections to a binary. What a lot of people do when they try to add sections to a binary is just they see, okay, my section headers are here, it's an array, I'm just going to go to the next offset and add another section header, and everything will be magic, because it's always going to be nulls there. There's always going to be plenty of padding. There's no problem. Problem is, you're not always going to have plenty of padding, and notepad.exe is one of those specific examples where you do not have enough padding. I have enough padding for one section maybe, but I think in this particular example, if I add two sections, I'm actually going to be overwriting part of my import table. That's going to be bad news. So inject -i -o. So here I just ran binject to create another new notepad.exe. I'm just going to rerun this command again with the input being itself. And I'm going to just keep doing this over and over and over. I'm going to make a bunch of sections. Now I'm going to PE view that. And you can see, of course, it made a whole bunch of sections here. So clearly I've exhausted what I could have achieved using the slack space in the header section of this PE binary. So what it's actually done, if I notice the first section in this binary actually begins at the offset 600 instead of the original 400. So what binject does is actually completely restructures the binary if it needs to. If it is able to detect that it doesn't have enough slack space left in the end of that headers, it detects that there's something there, like the import table, it's actually going to restructure the binary such that it can actually make space if it needs to. So it's pretty well done in that perspective. And a lot of these basic features, like the adding the import DLLs and stuff like that, are pretty hardened because we're using them. Been using them for a while on internal projects, so that they work very well. Anything that's edgy might not be as flushed out, and you might get bugs and crashes. But some of this stuff is pretty good. So, any questions? Just deer in a headlight. Okay. All right. Well, thanks. Once again, here's my information. Nick Harbour. And the tool, the binject, and the proof of concept for the new process injection technique is on my website. You can download it, whatever. Give me your thoughts. And thank you.